Good day, everyone. We are going to be starting topic number 4, unit number 4 in today's lesson. This unit is on trigonometry, and you've already done quite a fair bit with trigonometry in your previous courses. For example, Mathematics 1700, you learned how to solve for missing sides, missing angles in right triangles, but also in non-right triangles, what we call oblique triangles, using the law of sines and the law of cosines. What we're going to do here in this lesson right now is just a review of something that you did in Mathematics 1700 anyway. And this is solving trigonometric equations using inverse trigonometric functions. So for example, here is a trigonometric equation. You're told that the sine of some angle, which you don't know, is equal to 0.5. Well, in this case, the theta, the unknown angle, that is your variable. And to solve your variable, to solve for the angle, of course, you'd have to use inverse sine using your calculator of whatever the argument is, 0.5 in this case. The solutions that you get back, just like you did in Math 1700, should be between 0 and 360 degrees because we want them to be angles in standard position. There's going to be two possible answers for most of these anyway. And we're going to learn here now, how do we find those? How do we solve for those unknowns? Here, this is on page 2 in your notes. You have your quadrants set up, your x-axis, your y-axis, and you will recall, I hope you will recall, that in some of the quadrants, certain trigonometric ratios are positive and certain trigonometric ratios are negative. So for example, in quadrant number 1, the sine is positive, the cosine is positive, and also the tangent is positive as well. In quadrant number 2, the sine is positive, the cosine is negative, and the tangent is also negative. In quadrant number 3, both the sine and the cosine are negative, but the tangent is positive. And in quadrant number 4, you'll notice that the sine is positive, sine is negative, sorry, the cosine is positive, and the tangent is also negative. Now what about the reciprocal ratios? What about, for example, cosecant? Where is that one positive and where is that one negative? Well, because the cosecant is equal to 1 over sine, it's positive and negative in exactly the same quadrants that the sine is. So if you ever see a question, and you will, where is the cosecant negative, where is the cosecant positive, you basically just use your rules for sine, and that will tell you as well. Now, by the way, all of those positives and negatives there, we were kind of tying that up, putting that into a rule which we were calling the CAST rule, C-A-S-T. Now, of course, what do these letters stand for? The A stands for all, meaning all the ratios are positive in quadrant number 1. Quadrant number 2, only the sine is positive, and its reciprocal ratio, which would be cosecant. In quadrant number 3, only the tangent is positive, and again, its reciprocal ratio, the cotangent. All the others are negative. And in quadrant number 4, the cosine is positive. All the others are negative, except for the reciprocal of the cosine, which is secant. That one is positive as well. So you're going to be using this CAST rule in the next review questions that we're going to be looking at. Of course, your first calculation, you're not usually going to be calculating theta, not right off the bat. You're usually going to be calculating the reference angle first. And in Math 1700, you were referring to that as alpha. Well, you can still call it alpha here if you like. The reference angle is always formed between the terminal arm. Remember now, these are angles in standard position. The initial arm is always pointing along the positive x-axis. That one is fixed. That one does not move. But the terminal arm is free to rotate. And it can actually rotate in either direction. You could have positive angles and negative angles. A counterclockwise rotation about the origin would be considered positive. And that's the only ones we're going to be looking at here for these questions. So if your terminal arm right there ends up in quadrant number 1, the reference angle is formed between that terminal arm and the closest x-axis. So in this case, your reference angle actually is your theta if your terminal arm ends up in quadrant number 1. Here, quadrant number 2. What if this was your terminal arm, and here's your reference angle, and again, you can call that alpha if you like. Well, here is your theta. Again, starting from the positive x-axis, counterclockwise rotation to that terminal arm. And to calculate your theta right here, of course, theta would actually equal 180 degrees minus your reference angle. If you are calling that alpha, that's what it would be. If your terminal arm ends up in quadrant number 3, here's your reference angle right there. Notice again, formed between the terminal arm and the closest x-axis. Reference angles, by the way, are always less than 90 degrees. They can't be bigger than 90. They have to be less than 90. And so here's your theta right there. Now you can see theta in this case is going to be between 180 degrees and 270. And in order to calculate your theta in this case, you would take your 180 degrees and you would add your reference angle alpha. And finally, what if your terminal arm ends up here in quadrant number 4, like so? Here's your reference angle, again formed between the terminal arm and the closest x-axis. Here is your theta, the angle that you're after. And in this case, to calculate your theta, it would be 360 degrees minus whatever your reference angle is. Okay, that's how you know what your solutions are going to be. And remember, you're going to have 2 solutions for each of these trigonometric equations. Here, the rules are summed up in this table on the bottom of page 2. I usually don't ask students to memorize those formulas. I just say make those little diagrams right there. Make a small sketch. And it's quite obvious then what you have to do to get your 2 thetas. So we're going to work on a few of these questions here now. This is on page 3. I've got a few select ones I'm going to pick out. And before I do them, I want you to read the question carefully because there are certain things about the question that will tell you, first of all, how many solutions should we find, and should your solutions be in degrees or should your solutions be in radians? Remember now, you did radian measure back in Math 1700 as well. So this example number 1 on the top of page 3, first of all, starts out by saying, in each of the following, find theta. So these are trigonometric equations. And this part right here is very important if you look at that carefully, because first of all, it tells you that you should have your answers in degrees in this case. And because they're looking for all of the solutions between 0 and 360, you're going to get 2 solutions for each of these equations right here. All right, 2 solutions for each one. So let's go ahead and try some of these. I've got a few picked out. We won't do all of these, but if I show you a few of the examples, how they're done, and then you go ahead and you try the rest of them, including the practice questions that on page 4. So let's go ahead. Let's start here. Let's try example 1, part A. This one looks pretty straightforward. So what we have here, we're told that the cosine of some angle theta is equal to 0.3527. Well, the first question you need to ask yourself, and I'll just jot down that diagram for the cast rule over here. It's important to remember that, by the way. All right, CAST. And you can see that this cosine ratio is positive, isn't it? So you need to first of all ask yourself which 2 quadrants, and there will be 2 of them, which 2 quadrants have a positive cosine. So if you come over and look at your diagram for the cast rule, well, they're all positive in quadrant number 1 anyway. And this C here in quadrant number 4, that means that the cosine is positive in quadrant number 4. So I'm going to set up a little diagram right here, and I'm just going to put one angle up in quadrant 1 like that, and another angle down in quadrant 4 like that. Now, are they accurate? Probably not. doesn't matter because I'm only using this as an aid to help me determine what the solutions actually are. Now, here's my reference angle in quadrant number 1 between the terminal arm and the closest x-axis. Here's my reference angle in quadrant number 4 between its terminal arm and, again, the closest x-axis. So remember what you're doing. You're actually calculating the reference angle alpha first before you even get your thetas. And so you're going to work out the inverse cosine, inverse function of 0.3527, whatever that is. So take your calculators. I've got my calculator here with me. Make sure your calculator is in degree mode for these questions. By the way, because you're working at the reference angle first, if this ratio had been negative, I would have dropped the negative sign. Do not use the negative sign when you're calculating your reference angle, because if you do, your reference angle is not going to be between 0 and 90 degrees. And that's exactly what you want to happen. Okay, so make sure if there was a negative there, you would drop it. And I'll do an example like that momentarily anyway. So I take my calculator. I make sure my calculator is in degree mode. Okay, mine is, and all I type in is the inverse cosine of 0.3527, and I'll round the answer to 1 decimal place. So what I get is that alpha is equal to, and I'm just reading directly from my calculator here now, I get 69.347. Okay, so that's 69.3 degrees. Now, that is my reference angle. So what I'll do now is come over to my diagram that I created just a moment ago, and I'll fill in as good as I can with this stylus anyway. There is one angle of 69.3 degrees. And down below here is the other angle of 69.3 degrees. Okay? Now remember, they might not necessarily be theta, but it turns out that actually one of them is. Because the reference angle is in quadrant number 1, then it's theta. Let me just change my ink color here so you can see my theta. Here is the first value of theta. All right, again, starting from the positive x-axis, a counterclockwise rotation until you run into the terminal arm. So it turns out that for this one right here, theta is equal to, in that case, 69.3 degrees. So there's your first value of theta. In fact, if you wanted to, you could even call that theta 1. That's your first theta. What about the other value? Because remember, there's going to be 2. What's your second value of theta? Well, again, that starts from the positive x-axis, makes a counterclockwise rotation all the way around. You were doing something like this back in Unit 1 as well for complex numbers when you had to change to polar form. Remember that the angle in polar form had to be in standard position between 0 and 360 degrees. So this is like that. Now the calculation that you would do here to get your theta is actually 360 degrees, which is what it would be if you went all the way around, minus 69.3 degrees. And if you type that into your calculator, I'm pretty sure you're going to get 290 degrees, 290.7 degrees. So there's your 2 values of theta. All right, now this is exactly what you were doing back in Math 1700. Exactly what you were doing. And the other examples on this page are done pretty much the same way. Now I'll do another one for you here. Let's do B, because B actually has a negative sign. So it's important to know what to do if you have that. All right, so I'll just erase. Actually, I'll just wipe that out. All right, hopefully you had it all down. Remember, all of these videos, you should be watching them. Classes are recorded as well. All right, they're posted up on D2L in cloud recordings under Zoom. All right, so let's try B. Well, I'll erase that other part too as well. Let's try B next. See how that one works out. Should be fairly straightforward. Okay, so again, the sign is negative. The first thing I would do there is I would make a little diagram and I would ask myself, using my CAST rule, which two quadrants have a negative sign? Well, in this case, that would be the quadrants where the sign is not positive. So let me see. It's positive in 1 because they're all positive in 1, and it's positive in quadrant 2. So in this case, the sign is negative in quadrant 3 and in quadrant 4. So in my diagram, I make a little angle like that and a little angle like that. Okay, here's my reference angle between the terminal arm and the closest x-axis, and here's my other reference angle on the other side. So again, I'm going to calculate my alpha. It is definitely the inverse sine, but now do not use your negative. Leave the negative out. So it's just positive 0.742. Oh, my neighbors upstairs are a little loud this morning. Okay, so again, just take your calculator and we will type that in. What will we get, I wonder? Remember, it should be between 0 and 90 degrees. And I get 47.90. Well, I'm going to call that 47.9 degrees. Okay, that's my reference angle. So again, I come over to my diagram, and in those little angles right here, I put in 47.9, right there, something like that, and I put in 47.9 right there, something like that. That's my two reference angles. Now my theta, of course, is not 47.9. One of my thetas will start again from the positive x-axis and go all the way around to there. That's one theta, my first solution. And the second one is again going to go from the positive x-axis all the way around to that terminal arm. Okay, so in this case, what are we going to have for theta? Well, theta 1, the first solution, is 180 plus 47.9 degrees, and that should be 227.9 degrees. And my second solution, my theta 2, would be 360 minus 47.9 degrees, and that I'm pretty sure is 312 degrees and then 0.1, 312.1 degrees. By the way, you can check these solutions, just like you can check the solution of any equation. If you were to type into your calculator the sine, right, of 227.9 degrees, remember now all you're doing is you're substituting the solution back into the original equation to see if it's true, you see. If you type that into your calculator, you should get a result very close to negative 0.742. It won't be exactly that because, of course, we rounded theta, didn't we? We rounded the reference angle. So there's going to be a little bit of discrepancy there, a little bit of error, but it should be very, very close to that result. Okay? Now, what else? C, D, E, and F, they should all be very, very similar to that. I'm going to do one of these right here, G, H, and I. Now, how are these different? Well, these are different because now you're not given the three primary trigonometric ratios, sine, cosine, or tangent. Now we're given the reciprocal ratios. We have cosecant here in G, we have secant in H, and we have cotangent here in I. Now your calculator doesn't have a cosecant button or a secant button or a cotangent button. So you might recall there's something you'll have to do. Let's try H. I'll do H right here. So what I'll do, I'm looking at secant equals negative 1.155. Well, secant is actually the reciprocal of the cosine ratio, isn't it? Okay, so what I'm really going to do here, think of it as this. I'm going to take both sides of this equation and I'm going to flip both of them over, or I'm going to take the reciprocal of both of these sides. All right, so really that's what I'm doing. I'm taking the reciprocal. Now, if I take the reciprocal of secant, 1 over secant is cosine theta. Okay? And then what I do is I take the reciprocal using your calculator. And there's several buttons you can use to take the reciprocal, by the way. You could just type in 1 divided by negative 1.155. That would work fine. Or also you could use the reciprocal button on your calculator that looks like this. if you just type in negative 1.155 and hit that button right there, your calculator will automatically take the reciprocal. Now write down the reciprocal to 4 decimal places. So it's going to be negative 0.8658. You see that? And now it's just like the ones that we've been doing. Instead of solving secant theta equals negative 1.155, you're going to solve cosecant theta equals negative 0.8658. So again, that would be just a matter of, I'd like to do it this way. Now ask yourself which quadrants, here's your CAS rule once again, which 2 quadrants have a negative cosine? Well, according to the CAS rule, that would be 3, so I'll go like that, and 4, and I'll go like that. Okay, so again, here's my 2 reference angles. That's what you're going to calculate first, your alpha, and that would be the inverse cosine of, now drop the negative, no negative sign, 0.8658, 8. There you go. So I'll type that into my calculator. And again, they want the answer in degrees, and there's going to be 2 of them once again. So I'll just go inverse cosine of 0.8658, round that to 2, or 1 decimal place, sorry. Now I get 30.02, so I'm going to call that 30.0. And there is your reference angle. So I come over to my diagram once again. There's my 30.0 degrees, and there's my 30.0 degrees. See that? The reference angles are always the same. So one of my thetas is going to start from the positive x-axis in standard position. It's going to go to there. And you can see what you're going to have to do, right, to calculate that theta. That's your theta 1. That's going to be 180 degrees minus the 30 degrees. And your second possible solution, again, starts from the positive x-axis all the way around to there. So that would be 180 degrees plus 30. So your theta 1, your first solution, is going to be 150.0 degrees. And your theta 2, your second possible solution, is going to be 180 plus 30, and that's going to be 210.0 degrees. All right, so there's your 2 solutions here now. And again, you could check those if you wanted to. All right. So hopefully you remember, you recall how to do all those types of problems, those types of questions. I am going to do another one from example number 2 here as well. I want you to look carefully at example number 2. I'll make sure you have time to write down the answers from the previous example first. But in question number 2, example number 2, how are these different from example number 1? All right, it's still saying find theta. You're still asked to find an angle, and you're still given a trigonometric ratio in each of these cases. Now I notice these 3 are the primary ratios, sine, cosine, tangent. They could have just as easily given you one of the reciprocal ratios here as well. So what's different, everybody, I'm just going to erase some of this here right now. Hopefully you all have that copied down. What's different here is your solutions. There's still going to be 2, yes. You're still going to have 2 solutions. But look at this right there. Now that means that your solutions this time have to be in radians. So what you need to do for these questions right here, and notice it's important to read the question carefully, isn't it? 0 radians is the same thing as 0 degrees. 2 pi, if you recall from Math 1700, is also 1 complete revolution. So really it's the same thing as 360 degrees. So here's your 0 or 2 pi. All right, 1 complete revolution. Half of a revolution, by the way, 180 degrees, that is what we call just pi. That's pi radians. All right. So again, depending on where your terminal arm ends up for your 2 solutions, you're not going to be saying now 180 plus or 180 minus or 360 minus. Now it's either going to be pi plus or minus your reference angle, or 2 pi minus the reference angle, not 360 or 180 anymore. So let's try, which one shall we try? Let's try C right there. Let's try C. Okay, this one says the tangent of some angle is equal to negative, notice that, uh, 0.8391. So what I'm going to do is I'm going to set up my diagram just as I previously did, like so. Now you look back at your cast rule. Where is the tangent negative? Well, the tangent is positive in quadrant 1, and it's positive in quadrant 3, according to the cast rule. So it must be negative here in quadrant 2, something like that, and negative down here in quadrant number 4. So now there's your reference angles. There's your two reference angles. Okay? Now make sure your calculator this time is in radian mode, because you're going to be getting your decimals, your answers as decimals here now. And for radians, it's important to use 2 decimal places. Why do you need 2 decimal places for radians? Well, because radians are a lot bigger than degrees are. All right, 1 decimal place for a degree is actually pretty accurate. That's fairly precise. 1/10 of a degree is a very small angle, but 1 radian is actually almost 60 degrees. It's a little bit over 57 degrees. So if you just go to 1 decimal place for a radian, your error could still be like between 5 and 6 degrees. And that's a pretty big error. So always go to 2 decimal places for radians. All right, so here we go. Let's get my alpha. That is equal to the inverse tangent of, now again, do not use the negative. Drop the negative. Just go positive, 0.8391. All right. Now let me see what I get on my calculator. You can type it into yours as well. 0.8391. And I get approximately 0.6981. Now that's radians, remember. So if I round that to 2 decimal places, that will become 0.70 radians. Okay, notice that I'm not using the degree symbol here, and which is why I stress in a lot of my quizzes and in a lot of my tests, if you mean for an angle to be in degrees, you had better put that degree symbol there, because technically, if you don't use that degree symbol, then your angle is technically radians. So that's why it's important to use the degree symbol if your answer is in degrees. Anyway, I come over to my diagram. Here, look. There's one reference angle, 0.70 radians, and the other one is down here, 0.70 radians as well. So one of my solutions, one of my thetas, excuse me, will look like this. You can call that theta 1, and the other one, again, from the positive x-axis all the way around to there, and you can call that your theta 2. All right, so what are my theta 1 and what are my theta 2? Now, I'll put down here exactly what I'm doing to get my thetas in these cases right here. One of my reference angles ends up in quadrant number 2. So to calculate my theta, remember now, halfway around is pi. Excuse me, not 180 anymore. So one of my answers would be pi minus 0.70, which is my reference angle. And that should give you 2.44 radians. So there's one solution. And your theta number 2, your second solution, you're going to have 2 pi, which is a complete revolution all the way to there. So that would be 2 pi minus the reference angle, 0.70. And so that's going to give you approximately 5.59 radians. And there's your 2 solutions right there. Okay, there's your 2 solutions. So that's how you solve these trigonometric equations for radians. But again, let me stress the importance of reading the question carefully. That little 2 pi symbol right here, that should indicate to you that the solution should be in radians, okay? Now, what about example 3? How is that different from the ones that we did? Well, the only reason this one is different right here is because now, if you read the question carefully, you might not end up with 2 solutions now. All right, you're not going to end up with 2 solutions. What does that mean? Well, let's try A right here. Let's do A. Okay? This one says the sine of theta is equal to positive 0.7313. Now, ordinarily, if that's the only thing you looked at, you would say to yourself, which two quadrants have a positive sign? Well, that would be quadrant number 1 right here, something like that, and quadrant number 2. I'm just putting check marks now in the appropriate quadrants, okay? So that takes care of this little piece right there. That would be quadrant number 1 and quadrant number 2. I can see by this piece on the end that they want the solutions in degrees. Okay, so take your calculator now. Make sure you take it back out of radian mode and put it into degree mode. All right, so I've got mine in degree mode once again. Now here, right in the middle, let me just change my ink color. That little piece right there kind of changes, well, not everything, but it changes something. It changes a lot. This is also saying that the cosine of theta is less than 0. Now, ask yourself this question. Which two quadrants have a negative cosine? All right? Because that's going to play a part in our solution here now. So, where is the cosine less than 0? Where is it negative? Well, according to the CAS rule, that would be quadrant number 2 right there and quadrant number 3 down below. So the question now becomes, ladies and gentlemen, which one quadrant has both of those things being true? All right, so where is the sign positive and at the same time the cosine negative? Well, if you did what I did over here in this little diagram, just look for the quadrant that has 2 check marks in it. So there, you see that? Quadrant number 2 is the only quadrant where both of those things are true. So really, that's the only thing that you have to keep in mind now, is that when you find the solution to this trigonometric equation, instead of having 2 solutions, there's only going to be one, and it's over here in quadrant number 2. You're going to get your reference angle first, just like you usually do. Here is your theta, though, in standard position. And really, now it's the same thing. It's really the same type of calculation now. Everything is exactly the same. What you would do is get your reference angle first. Alpha is equal to the inverse sine of positive 0.7313. If that was negative, I would have dropped it, but it's not. And so here, when I type all of this into my calculator, inverse sine of 0.7313, and I get 46.995. Well, I'm going to call that 47.0. Go to one decimal place for degrees. So there's my reference angle. So I come over to my diagram just like I did before, and that angle right there is 47.0 degrees. So your theta, you can see here, is going to be 180 degrees minus that 40, that should be a 4 there, minus your 47.0, and so what you're going to end up with is 133.0 degrees. There's only one solution in this case, all right, only one, not 2. And in fact, if this was a question on a test or a question on a quiz, if you gave 2 solutions, you would lose part of a mark because one of your solutions doesn't solve both of these conditions right there. It has to solve both. Example B, 3B is just like that. Cosine is positive. All right, so there's one condition. Now, if you ask yourself which quadrant has a positive cosine, well, according to the CAS rule, that would be quadrant 1 and quadrant 4. Okay, but the next little piece says that the cosecant is negative. The cosecant is less than 0. Well, the cosecant will be negative in exactly the same quadrants where your sine is negative. Exactly the same, because they're reciprocal ratios, you see. So where is the sine negative? Well, that would be in quadrant 3 and quadrant 4. So now you can see that part B, the only solution, will be in quadrant number 4. So you go ahead and check that out and you find that solution there, okay? And there's one more there that I'm going to have a look at because this one's a little different. I've actually had students say, what do I do here? How do I solve that part C? Well, let's just have a look at it. Let's have a look at it right here. And it's actually is almost too much information, to be honest with you, here. First of all, notice that the solutions have to be in degrees. Okay, that's no problem. This first little piece right there tells me that the cosine is negative. All right, so which two quadrants have a negative cosine according to the CAST rule? Should be 2 and 3. And then this little piece, look at that. That little piece right there says that the tangent is positive. Well, in which two quadrants is the tangent positive? Well, that would be quadrant 1 and quadrant 3. So you can clearly see that for C, the only solution, there's only going to be one again, is in quadrant number 3. That's the only one. But here's where students sometimes have the difficulty. They're not sure. Which one of these do you find the reference angle for? Do you find it for the first one? Or do you find it for the second one? Or do you find it for both? Well, ladies and gentlemen, if this problem has been set up correctly, validly, it shouldn't matter which one you go ahead and find the reference angle for. They will both give you the same solution, okay, for theta. So it's not necessary to do it for both. You can do it for either one that you like, but remember, your only solution is going to be in quadrant number 3. That's all. So if you wanted to do it this way, let me set up my diagram here now. Quadrant number 3, there's my reference angle. If you wanted to find alpha as the inverse cosine of positive 0.7880, that would work absolutely fine. And so what you get in this case right here, let me check my handy dandy calculator. Inverse cosine of 0.7880, 38.001. Well, I'm going to call that 38.0 degrees. Now that is my reference angle. That's not my solution. That's my reference angle. 38.0 degrees right there. So you can see that your theta is going to be equal to 180 plus that. So that should be 218.0 degrees. Now, if you had gone ahead and instead of using the cosine ratio, if you had found alpha this way, inverse tan of 0. Positive 7813, you'd get exactly the same answer for alpha. All right, you'd still get 38.0 degrees. And therefore, you'd still end up with your answer, your theta, being 218.0 degrees. Okay, kind of a long video, isn't it, for a review? But I wanted to go over one of each type of examples just to make sure that you saw everything. So what you should do now is the practice, or even the questions here, the examples that we didn't do in this video. Now I may go over some in class, or the practice ones, but you try all of these now. Remember, your solutions are posted on D2L. You shouldn't have really any difficulty with any of those. I hope not anyway. Practice question in number 1, they want the answer in degrees. And it looks that there's going to be 2 solutions for each one of these, A, B, C, D, E, F. For question number 2, find in each of the following, find the value of theta that satisfies the given conditions where 0 degrees is less than or equal to theta, which is less than 360. So here they want the answers in degrees as well. But now you're going to have just one solution in each of these cases. All right, so that's it for those practice ones. You try those. And if you have any difficulties, make sure you let me know. All right? But I don't think you'll find these hard. This is just review material anyway. So I'll stop this video there. Kind of a bit longer than I was expecting it to be, but you have a look at these and you shouldn't have any trouble. Okay? Bye-bye for now.